Hey folks, in this video I'm going to be talking about how to read a file format specification. So in the previous video we introduced the idea of binary file formats, or binary file storage, and we also discussed how they end up being more efficient. So let's take a look here. This is talking about image formats. So you see this nice little dog up on the screen, that is of course Wonder Bread. Images are an example of basically files that contain a lot of information. Think about the fact that that image is basically made up of a bunch of different pixels, and each pixel has a different color component. Typically they have red, green, and blue components. Each of those is numbers. And so an image like this, which is 152 pixels by 152 pixels, has hundreds and hundreds and hundreds of numbers that describe the image. Now, if we want to use a text-based file format, that's going to take a whole lot of storage. It kind of makes more sense if we have our image stored as a binary file. It'll be a lot more compact. And so that's what they typically do. BMP is an example of a binary file format. It's pretty old at this point, but it's kind of nice because it's supported across many different platforms and it's relatively simple. It doesn't have a bunch of different formats that we have to support. We can kind of figure it out on our own. This particular format is described, well, for me, I read the description basically from Wikipedia. Typically, when you're working with a file format, whether it's binary or text, there'll be some sort of a technical description of it somewhere. I like the Wikipedia one in this case just because it has a nice graphic, which is shown on the right-hand side of the screen. So the natural question is basically, how exactly does this thing work, right? So there are a bunch of ones and zeros, right? A bunch of bytes that represent this, nice picture. So what are those? How are those kind of ordered? Well, that's described on the right-hand side of the screen. So this is what I'd call a file format specification. You can see that there are three overall regions. There's kind of this green region over here, blue region, and yellow region, okay? So that's called, the first one's called the bitmap file header, then the dib header, then the image data. Just thinking about conceptually for a second, there's kind of, maybe three pieces of information, right, that typically we would have about an image. The first is, just information that it is an image, right? Basic stuff. That's what's captured by the green region. Then there's the dib region. What that's capturing is like, what does your image look like? So for example, the width and the height. Again, very basic information about it, right? So that blue part is basically describing the image, right? The green part is describing that it is an image. The final details, of course, is the actual image itself, right? The actual pixel itself. That's captured by the yellow part below, right? So that's the actual image data. So those are our three different overall regions, right? At a high level, right? Knowing that it's an image, describing what type of image it is, and then actually giving that pixel by pixel description of what it is. So that's what we're looking at here. Now as we drill down, we have to kind of look at the description of how the bytes in the file are structured. Now, we can kind of start at the top here. It's read basically top to bottom, left to right. That's how this thing is read. Initially, we start at the beginning of the file, which is over here. That's like if you open the file, what do you first see? In this case, the very first thing we see is a signature. Now, a signature is kind of just like a piece of data. It stores a signature. How much does it take? It takes 2 bytes. That's what the diagram is showing up top. 2 bytes over here, and you notice that kind of the width of signature lines up with 2 bytes. So signature is 2 bytes. Whereas if we look down, the next piece of data in order is file size, which is going to be 4 bytes, because notice it spans the entirety of this diagram here. So this is 4 bytes. Then again, right, this is 2 bytes over here because it's halfway, 2 bytes over here because it's halfway, 4 bytes over here, right? So as I read this diagram, I can see from it how much space is allotted to each of these. That said, it's a little bit tricky to figure out how to read these or how to interpret these because I don't know that much about the information that's being stored there. Now for me, I've looked at the spec in more detail, so I already happen to know file size is an integer. File offset is an integer. Reserve 1 and 2 don't really have a format. Signature is actually going to be 2 characters next to one another. All right, so if we're looking at this right though, our first step is kind of figure out how many bytes is associated with each piece of this, right? And it goes on, right? So I could look at each of these, right? These are kind of like 4, 4, 4, 4. They're almost all 4 except for these over here. These are both 4, or both 2 bytes. All right, looking at the overall regions, I can kind of sum these up. This is a total of 14. This is a total of 40, right? These are typically fixed sizes. The reason basically being is that when you're looking at a file, right? I mean, it might be bigger or smaller based on how many pixels it has, right? How large the image is. But we need to have a fixed size header because otherwise when somebody opens your file, they won't know where to begin, right? There should be a fixed size header that basically tells you what to expect, right? Sort of like a preview or a summary. That's what this is here. Then the rest of the data, which has a variable length, I'll just write VL over here, is stored in that pixel array. This is what might be vary, right? So I don't know how big it's going to be. Typically, it's substantially better than the stuff up top. Down here, it's basically just a 2D array. 2D array of pixels, where every pixel takes up 3 bytes, because you need 1 byte for each color component, right? For example, RGB. It won't quite be RGB for us here, but just think of it for now. So basically, a 2D array where each element is worth 3 bytes. And then because there's a special rule here for BMP, every row has to be a multiple of 4 bytes. All right, so at a high level, that's what this format for specification is saying. Eventually, we'll go through it with a hex editor as well as a C program, and we'll kind of see, exactly how things go together. As a final note, right, this is kind of to drill down a bit. This is what it looks like if we have a very small image, specifically a 2x2 image, which is what's being shown here. It basically has 4 colors that are all kind of pure, right? Pure blue, pure green, pure red, pure white. And based on that diagram from before, that stuff up top maps downwards, right? This maps into this. This is our hex editor. This is showing the different bytes in our program. And for example, right, my color, for example, pure white, which would be represented FFFF, is over here, right? So this little bit maps over here. This little bit over here maps over here. And then if I look, actually, I can see, right, the fact that it's a 2x2 is over here, right? This is my length and my width are over here, 2 and 2. So that file, right, gets translated, right, from what I see on my screen into this hex format, into this binary format, and it ends up being nice and compact. All right, that's all I got for now. Hopefully you guys have a decent idea now of how binary file format specifications work. That's all I got, and I'll see you guys in the next video.